Professor Pavaskar sir for giving me this opportunity to share my thoughts. Although let me confess at the beginning that I am not the expert in climate change, but since as a common citizen and as an officer from the Water Resource Department, we have to deal to this international issue of climate change. So in today's, I will not say it as a lecture. I will say it as a discussion, because everyone from this batch has a potential to contribute, and everybody is expert in his domain or her domain. So I can see a very renowned officer from my department, and that's why I feel that this session should be very interactive. And I feel that barring few participants, most of the participants can speak in Marathi, but some participants, I feel that they may not be comfortable in Marathi. So I will keep my session discussion in English language only. So sir, kindly grant me access for sharing the slide. Yeah, I got it. So I will share my presentation. Can you see my presentation?
Yes, sir.
Yes, sir. Yes, sir.
Thank you. So today we will discuss about climate modeling and prediction techniques. So before starting this discussion, let me tell you that climate change is an evolving phenomena, and this phenomena is very complex, and based on the data of the climate and atmosphere, we try to model the climate situation, and using our model, we try to predict the future scenarios. So there are possibilities of errors at each and every level of the modeling. For example, when we try to model any climate change model, we require some data. So whatever data is required, we will discuss in the due course of presentation. But to give a overview why this topic is evolving topic, and why there are issues and challenges in climate modeling, and there is a need of further development. This is because there are issues in data collection. So since climate is a very complex process, it involves various cycles and activities. We cannot gather each and every parameter. So what we can say, what is the atmosphere, what is climate? Climate includes temperature, humidity, wind velocity, clouds, wind pressure. All these factors contribute to climate. But when we try to model a entire ecosystem, it is very difficult to model into definite parameters. So there arises some error. Then while modeling this climate model, we have to use some mathematical equations. So there also some assumptions are there. And when we predict based on our model, there are also scenarios. And these scenarios are also based on some assumptions. So this entire topic of climate modeling and prediction is an evolving topic, and in due course of time, you will learn that why there are challenges. So in this presentation, my focus is to make you aware about the various climate modeling approaches and prediction techniques, and give the overview of international climate modeling agencies, basically IPCC, and the modeling of the Indian monsoon. So I will start. So I had divided my presentation into 4 parts from the convenience point of view. In the first part, we will discuss about the climate change, and we will also discuss about the climate models. In the second part, which is the most important part of the presentation, is basics of general circulation model, or it is also known as a climate model, global climate model. The short form remains the same. Either it is a general circulation model or global climate model, and then regional climate model. So these two terms are self-explanatory. General circulation or global climate model means modeling entire Earth, whereas regional climate model is a modeling specific location on the Earth. That location may be the at the scale of country, or at the scale of state, or maybe at the scale of district. So we will see in the presentation what are the techniques of modeling and what are the challenges. In the third part, I will highlight the role of Intergovernmental Panel on Climate Change, IPCC, the highest scientific and technical body on climate change. Then we will discuss various climate models and scenarios projected by the IPCC. And in the last part, we will discuss about the way ahead and future work. So we will start with the climate change and climate models. So first, we all know that climate change is a global phenomena, and this phenomenon refers to basically very significant activities which result in long-term changes in the Earth's climate pattern. And this climate change phenomena is typically attributed by the human activity. See, over the evolution of the Earth phase, every time climate changes, but because of the human induced activity, the rate of change of the climate is increased, and because of the issue, the global warming and greenhouse effect, we are witnessing the adverse impact of the climate change. So climate change refers to the significant long-term changes in the Earth's climate patterns, which are attributed by the human activities. And this activity includes burning of fossil fuels, deforestation, and industrial process. So these activities are started within the last 100 and 150 years, and we can see that from the data and climate models, we can visualize that since last 100 years, the rate of change in the climate is accelerated, and we human are the responsible for the same. So in this presentation or in every discussion about the climate change, we generally hear three terms. First term is climate change, second term is global warming, and third term is a greenhouse effect. So in very brief, I will try to explain these three terms and how these three terms are different but interrelated. So as we define the climate change, now we will shift our focus to the global warming. So what is global warming? So global warming is a human activity which are responsible for releasing of the greenhouse gases to the atmosphere. So this is very interesting to know. Although green word is related to, always we correlate green word to good activities like green waste, green water. But here, as far as climate change is concerned, greenhouse gases is a negative word. Why it is negative? Because when if you enter in any greenhouse which are or a poly house, we can feel that it has a controlled temperature. In that controlled environment, we can grow some vegetables. Same analogy applies with the climate. So what these greenhouse gases do, they create a controlled environment in the atmosphere of Earth, and this controlled environment causes global warming. So global warming and greenhouse gases are interrelated, and the greenhouse gases includes carbon dioxide, methane, and nitrous oxide. These three are predominant greenhouse gases, and these gases contributes the trapping of heat in the Earth atmosphere, and because of trapping of the heat, the Earth's average temperature increases, and because of that, we experience a phenomenon which is known as a global warming. So release of the greenhouse gases in the atmosphere is a basic contributor for the global warming. So if we understand the global warming, now we will deep dive in the term greenhouse effect. So human activity releases greenhouse gases into atmosphere. We just discussed these gases, and these gases get trapped in the atmosphere, and because of this, the temperature of Earth increases. So in this slide, we will summarize and correlate all these three terms. The global warming, first we will discuss, summarize the greenhouse effect. So greenhouse effect is the natural process by which certain gases trap heats in the Earth's atmosphere. So heat is being trapped in the Earth atmosphere, which results in the global warming. So global warming refers to the increase in the average global temperature, primarily caused by the human-induced enhancement of the greenhouse effect. And climate change encompasses broader changes in the Earth's climate system, resulting from human activities and other factors. So climate change, in the climate change, we are focusing on the long-term changes on the global weather pattern. So here are the two important parameters. First is a spatial distribution of the changes and temporal distribution of the changes. We are not speaking in terms of the changes in the atmosphere with respect to seconds or minutes or hours. We are calculating the Earth atmosphere changes with respect to years, decades, and centuries. As well as we are not talking about the changes in the atmosphere in a village or in a city or in a tehsil. We're talking about the changes in the Earth atmosphere on the Earth. So we are focusing on entire Earth because climate is an interrelated activity. So once we understand the climate change, greenhouse effect, and global warming, now we will discuss the impact of global warming. This is just a refreshing slide so that we will come on single page. So global warming leads to rising sea levels because of the increase in the temperature. The iceberg and glaciers melt, and because of that, sea level rises. It also results in more frequent and severe extreme weather events. So this is very important as far as our state is concerned and as far as our country is concerned, because our country is the 50% part of our country is concerned about the rising sea level, because the southern part of our country is covered or surrounded with the sea. So once sea level rises, the coastal area suffers the issues of cyclone or encroaching of the salt water or seawater on a land, and thereby polluting the fresh water and making soil saline, so that the fertility of soil gets reduced. Secondly, since we have a Himalayan belt, the melting of the snow on this Himalaya will also cause the extreme weather events, and we experience this in Uttarakhand and part of the upper areas. So more frequent and severe extreme events means sometimes we can experience drought and sometimes we can experience floods. So both the extreme events are possible. This global warming leads to the shift in precipitation pattern. So generally we had a defined monsoon period, but because of the global warming, there is a shift in the precipitation pattern. The generally monsoon arrives on 1st June in Kerala and 7th June in other place, but because of the climate change and global warming, we are experiencing that the arrival of monsoon and the dry spell within the monsoon are shifted quite a lot. This also results in the loss of biodiversity, and which is a bigger cause of concern, because this is a irreversible loss. Once biodiversity is lost, it is lost permanently. We cannot restore the biodiversity in our ecosystem. The next and most important is it results in the disruption of ecosystem and human societies. So how to address this challenge of climate change? So in order to address the challenge of climate change, we required concentrated efforts to reduce the greenhouse gas emission. This is one of the most important strategy proposed by the IPCC. So they force every country to reduce their greenhouse gas emission. So basically greenhouse gas emission is resulted from emission from the vehicles, emission from the factories and other activities, including agriculture. So IPCC enforces all the countries in order to reduce their emissions of the greenhouse gases. Second, how we can reduce the emissions? By by making a transition from coal-based energy sources to renewable energy sources. So if we shift from coal-based energy sources to the solar power or wind power or hydropower, our greenhouse gas emission will reduce. Third, we can improve energy efficiency. The improvement in the energy efficiency will also reduce the climate change scenario. We should protect and restore vulnerable ecosystems. So we have to study the climate, and for studying the climate, we need climate models. And one of the important aspect of the climate change is adapt the changes which are already underway. So adaptation to the changes is also important strategy for addressing the adverse climate change. And in order to address the impact of climate change, we have to measure the impact of climate change. It is said in the management that one of the important management principle is that cannot manage anything unless you measure it. So uh, hence comes the role of modeling. That is, in order to measure, in order to predict, we need to model, and that's why we have to model. So let's discuss what is a model. So very generically, as an engineer, we all know that what is a model. Model is a approximate mathematical formulation of the phenomenon. Generally, model is a mathematical model, but it is not universally truth. Some models are a physical model. For example, in order to study the backwater effect of the dam, we construct physical model also. So models are mathematical models, physical models, but as far as climate change is concerned, most of the models are mathematical and computer models, software-based models. So in very generic term, model is an approximate mathematical formulation of a natural or man-made phenomenon. And a climate model is a computer simulation model on the Earth's climate system, which includes basically four components. First component is the atmosphere. So we try to model entire atmosphere in our model. Second important component is the ocean. Third important component is the land and all the properties of land, and last is the ice. So these four components are interrelated components, and that's why if we want to create a climate model, we should capture these four important components. So these are the parameters of our model. What is the scale of our model? There are two scales of our model. One is a time scale. For our model, we require data since centuries. For example, if you want to study the impact of global warming from 1800 century, excuse me, do you have any question? We can discuss in between if you want. Hello? Sir, am I audible?
Yes, sir, you're audible.
Yeah, great. Yeah. So my request is, if anyone has a question, please interrupt me so that we can discuss. Huh? Okay.
Yes.
Yeah. So we want to model these four parameters on time scale. Suppose we want to model global warming levels in 18th century. We require data of 18th century. As well as if we have current data, that is data of 2024, we have to give this data as an input to our model. And based on the historical data, the model will project or predict future outcomes. So one of the scale of our model is a time scale, and second scale of our model is a geographical scale. So this data is required for entire Earth. So that's why we required ocean data, land data, ice data, and atmospheric data. So these models can be used to recreate the past climate conditions or predict the future climate situations or scenarios. So if we have a data of 200-year period for all these above four parameters, we can recreate the past situation. What was the past situation during the dinosaur period? We can recreate that using our model. It is another question whether how our model is related with the existing at that the actual scenario. So there may be a gap between the observed value and projected actual value and projected value. But if we want to minimize these gaps, there are steps to be taken. And if we undertake these steps, our model becomes more accurate and predictable. So generally, this climate change model is used to predict the future climate situation. So it is said that in 2050, if we continue the as its business practice, that is whatever current emissions levels are there, then in 2050 entire ecosystem will be in trouble. So how this conclusion is arrived at? This conclusion is arrived based on some model outcomes. So in the due course of time, we will discuss these models. So climate models are too complicated, and typical climate models includes enough code to fill more than 18,000 pages of printed text. Suppose you take a printout of a source code of a climate model, it requires at least an entire room to keep all the printouts of that code. So it is a huge and complex climate model, and as I mentioned, it is an evolving complex model. And because of the arrival of machine learning and artificial intelligence, so the climate models are self-learning. So they are evolving self-learning. They are getting data from all the parameters. Now our data collection system is also improved. So since I mentioned that our scale of climate model is the entire Earth, so it is not our model will not be accurate if we have data from across the globe. And as we know that most of our Earth surface is covered with the ocean, and we have a discrete data set of the ocean data. So in order to arrive at a climate model, we have to engage all the countries, all the scientists across the globe. So the World Meteorological Organization is a nodal agency which provides the data for climate model. And as far as India is concerned, Indian Meteorological Department is a nodal agency which collect the climatical data and supply this data to the WMO, and WMO verifies the data as per their norms, and this data is provided to the scientists. So World Meteorological Organization collect the data from each country, they validate this data, and this data is given as an input to the climate model. And in this way, the climate model is evolving. So climate model is too complicated, it has too many parameters, and data is collected on hourly basis from across the globe from various weather stations. So what is the need of climate model? If the climate model is too complex, too complicated, what is the need of this? So climate model help us to understand past climate variation and their causes. So what caused the climate change in the climate? If you want to study these models are very useful. If we want to test understanding of our climate system and to predict the future changes, so how future will change, if we want to understand this, we have to make a climate model. And third important objective of climate model is to project the future climate changes under different greenhouse gas emission scenarios. This is the most important use of the climate model from policy making perspective. So as far as policy maker is concerned, a policymaker knows that there is a big danger of the climate change. Policymaker also knows what are the impacts of climate change, and the policymaker also knows how to tackle the climate change. But while tackling the climate change, if we want to reduce the greenhouse gas emission, then our development also hampers, because as far as India is concerned, India per capita energy consumption of Indian citizen is just 20% as compared to the American citizen. So as we are developing, our energy consumption will be increased, and if our energy consumption is going to increase, then energy requirement will also increase, and if energy requirement is going to be increased, the greenhouse gas emission will also increase. So this is a Pareto situation. This is a situation in which both directions are challenging. If we want to develop, then there will be more emission of the greenhouse gases. If we stop our development, then country will lead to the poorer country. So in order to project the future scenarios, we have to build various greenhouse gas emission scenarios. For example, if our consumption is 100 units as of now, if what will be the impact of climate change if my emissions are 75% as compared to the 2024 emission levels? What happens if my future emissions are 50% of the current emissions. What happens if my emissions are 25% of the current emission? So these scenarios can be studied if we have accurate climate model. And based on this climate model, the Kyoto Protocol, which was developed, that means during the IPCC meeting, every country is supposed to control their greenhouse gas emission. And in order to devise that control measure, the climate model has been used. So this model, you can see that this is not only a mathematical model, but this model is a social and economical model, because most of the decisions taken by the policymaker are based on this climate model. The fourth important objective of climate model is to assess the potential impacts of the climate change on ecosystem, on societies, and on economies. So this is very important role of the climate change model. If you want to study the impact on change of ecosystem, so what will happen to the natural habitat? What will happen to the wildlife? What will happen to the vulnerable population? Then what will happen to the tribal communities, and how it will impact the economies of the states and countries? So we can study these impact if we have accurate climate model. Informing policy decision related to climate mitigation and adaptation. So these models are also useful in order to take the climate mitigation and adaptation strategies. If we want to identify uncertainties and gaps in our understanding, then these climate models are very useful, because climate is just like, as of now, climate is just like a black box. So there are so many parameters coming together and it forms a phenomenon. For example, lighting in a rain or falling rainfall itself is a very complex activity, and for having a precipitation over a given area requires so many complex parameters. And now we are talking about the climate of entire earth. So you can imagine that how complex this software or model will be. So once we understand the need of the climate model, we will discuss predictions and scenarios. Once our model is ready, so how we create a model? Basically, we collect the data, we look at the system. In our case, system is Earth system. As we discussed, Earth includes atmosphere, land, ocean, and ice. If we see these four parameters, we try to get the physical properties of these four parameters at regular interval of the time and at every location on the Earth. Once this data is collected, we correlate this data with the global warming or change in the temperature of the Earth's surface. So in order to do that, we have to construct certain mathematical formulation on our model. So models are of basically three types. If we know the cause and effect, then we can use predictable mathematical model. That means, for example, regression is a simple term. We can use a regression analysis. So on x-axis we have observation, on y-axis we have measurements, and we can fit a line in which, and using this line we can model that effect or phenomenon. So this is a one type of modeling. Second type of modeling is a black box modeling, in which we use mathematical model for which various type of inputs are given. See, and we have output, so that computer algorithm creates a weightage factor. It optimizes entire phenomena and it tries to give a equation for a given sort of model. And third is a machine learning based algorithms. So all these three types of algorithms are used for modeling. And once our model, climate change model, is ready, we need to calibrate the model. So how model is calibrated? Suppose if we take 100 years data for creating a model, we require another 25 years data for calibration. So once our model is ready, we provide some input for which output is known. So this input is provided and model output is measured, and model output is compared with the actual output. And if there is a deviation, we need to train the model. So training of the model and increasing the accuracy of model is a continuous process, and this process is known as a calibration. So once model is ready, it needs to be calibrated, and once calibration is done, we can say that we have a model which has a specific dependable or model which can give a result having specific confidence interval. So we can say that like that. So once our model is ready, it can be used to predict the future and make scenarios. So scenarios we had just discussed. So different scenarios for global warming can be studied to see the effect on climate. So once we know the scenarios, we can study the effect on climate change and global warming. So in order to do that, scientists divide entire Earth's surface into a three-dimensional grid and run climate simulation. So X, Y, and Z direction, the Earth surface is divided in a grid, and on each grid, model is run and outcomes are tested. Previously, these the grid squares were about 200 kilometer by 200 kilometer. This is a resolution of our model. So one grid cell. So in very simple language, I just want to simplify the concept. So suppose we take a photographs from our mobile camera. Earlier there was a 1 megapixel camera. So 1 pixel means uh, points per square inch. So 1 mega means 1 into 10 raised to 6 pixels in 1 square inch area is a resolution of 1 megapixel camera. So from similar analogy, our model, the climate change model, has a resolution of 200 kilometer by 200 kilometer. So you can see that our grid size is very large. But now scientists are able to calculate climate change using a grid that is 25 kilometer by 25 kilometer. This means that earlier study the climate change impact at district level. So for entire district, we had single value. But as far as a state like Maharashtra is concerned, many countries which are situated on the either side of the Sahyadri Valley, for example, on Ahmednagar, Pune, Satara, and Kolhapur and Nasik, the part of this district falls in high rainfall zone, and part of this district falls in the drought prone zone. But our model gives a single value for Pune district. So my model is not useful for me because the rainfall prediction using climate model or the weather parameter predicted using the climate model is similar for entire district. But in practice, the rainfall in a Bhor area is about 6,000 millimeter, whereas it is about 400 millimeter at Baramati. So within a span of 100 kilometer, rainfall changes by 90%. So that's why there are inaccuracies and limitation of the climate model. But now scientists are able to calculate the climate parameters using grid of 25 by 25 kilometer. Still, we have to do a better calculation because this is a mathematical approximation of the modeling. We need to drill down. So in future, we will get a climate modeling for a village level, that is 1 kilometer by 1 kilometer grid. But in order to do that, we need to take the data from 1 kilometer interval. So if we are able to provide a weather parameter data for each village, then we can predict the future outcomes for each village. So this is as I mentioned at the start of my presentation, this is an evolving model. So we cannot say that this model is completely perfectly okay and we can use this model perpetually. So this is the evolving model, and in future we will definitely improve this model manifold. The Intergovernmental Panel for Climate Change recently investigated the impact of 1.5 degrees centigrade of warming above pre-industrial temperature by using climate model. So this is very important finding of the model, that is they estimated that the average surface temperature of our Earth in 1850 year if that temperature is X, and if we compare today's temperature, then there is an increase of 1.5 degrees centigrade. So this much average surface temperature is increased, and this is resulting the global warming. And because of the global warming, we are witnessing the climate change impacts. So they had predicted various scenarios which we'll discuss in due course of time. So as I mentioned, reliability of climate model is one of the important factor, because we are taking a point data and we are applying this data for entire area. So that's why climate models are based on the physical principles that have been understood for many years, so these principles includes conservation of energy, and based on this principle, our fundamental understanding of climate and weather is based. Climate models are also checked by running simulation of past events. So if we have past data, past climate data, and past climate output. For example, if we have temperature data of 1870, and if we have average surface temperature data of year 2010, so using this data, we can train our model and we can test our model so that we can run the simulations. We have real world observations from the past, so we test if our climate model is accurate or not. And if our climate model is not reliable, all the decision taken based on this climate model will lead to failure. So before going to further topic, can we discuss something? If you have any doubt, if you need any clarification, I think we can take stop for 2 minutes and have a discussion. Sir?
Hello, sir. Pradyumna here.
Yes.
Wonderful presentation. What you gave us a complete overview. Couple of questions, sir.
Yes.
Now, assume that we are doing a suburban rail project, where as a part of my EIA and SIA, I'll have to show what are the kind of emissions coming and all, and then they will ask for a climate change report. Now, happening in a city like Bangalore, so obviously in your climate change models, there will be certain data prevalent for Karnataka, and then there will be certain data which is required for Bangalore, and that using those fundamental data, we can say, okay, I can say this is the kind of impact which will have the climate change impact it will have. So how do we drive down this macro what you showed now to the micro level that is on a project level? How do we drive down it for each and every project? What we do is a question which I have, sir.
This is a really wonderful question. And as a water engineer, myself and my colleagues are facing this issue. And the unfortunate answer to your question is there is no model as of now which can give you the localized climate change scenarios. So in due course of time, we will discuss global climate model and regional climate model. So in India, we have IMD and Indian Institute of Tropical Meteorology. So these two organizations, and along with the Indian Institute of Science Bangalore, IISc Bangalore, they created a model, but still that model has a special resolution which cannot predict predict the climate scenario at sub-district level. So this is one of the limitation of the climate modeling, and reason of this is a collection of the accurate data of the local level is difficult, and weather and climate is not a local phenomena, it is a global phenomena, and that's why it is quite difficult to get the local forecast from the climate model.
Hello.
Hello.
Thank you, sir. Thank you. Thank you, because we face this problem, especially when all these funded agencies come and fund the projects, and they will ask for all the greenhouse gas emissions, and then they will ask for climate change. And finally, when we give any, it becomes so difficult for us to give out any report because there is no data beyond the stage. And so the impact, whatever, though I agree with you that it's a work in progress kind of approach. But nonetheless,
Correct.
it becomes so difficult for us to convince these guys that boss, you
Yes.
can't take whatever UK data or whatever happened in these economies and relate that with India or big project. And unnecessarily the delay happens. Finally, we able to
Yes.
give some 10-15 page document, and
Yes.
God knows, I think they agreed. Otherwise, it becomes such a big bottleneck. Many a
Yes.
time. That's the reason why I asked you that question, sir. Thank you.
Yeah,
Thank you.
your question is really important. So I will cite an example of Maharashtra state. In as far as Maharashtra state is concerned, the state started its formulation of state adaptation plan for climate change. So that activity was given as a task to Terry. So Terry prepared a report in year 2008 and they submitted this report. Again, the issue was they gave their prediction based considering the district as a whole. For example, they predicted that there will be some district in the Maharashtra where precipitation will increase by 11%. But telling that precipitation will increase in Ahmednagar district by 11% is of less help for a policymaker from formulating the policy formulations for mitigating the climate change impact. So government not accepted the recommendation of the Terry report and again formulated again a new committee for proposing the proposing the recommendation for adaptation for climate change. So again, the report was submitted in year 2020, and again we are facing the similar issue. So this report also highlights the impact of climate change, but again these impacts are at the regional level. So we are facing this challenge, and we are continuously following with IIT Bombay and IITM Pune in order to give a local forecast. And there are some engineers like Rajendra and from my department. So these people are facing a issue of releasing of water from a reservoir. If I get an idea of precipitation over my catchment area of the reservoir, I can plan my releases. But this data, the prediction is not accurately available. So always there is a confidence interval associated with the prediction. So I am not damn sure about the my prediction. I cannot release the water from my dam. So this is a challenge we are facing, and I think you are also facing the similar kind of challenge. But I think we need to wait for some time, maybe some number of years. After that, we can get a localized projection for the climate change. Boris sir, you want to speak something?
Yes, yes. There is a
Yeah.
it was the United Nations Framework Convention on Climate Change or UN Climate Change.
Yes.
Or most of the nations have international commitment to bring down the carbon content, or they are directed their policies towards zero carbon.
And
So,
zero emission. Yeah.
IPCC in connection with that UNFCCC goal, whether these are interacting with each other to control the climate change or to bring down the targeted, that is 1.5 degree below predefined level.
Okay.
IPCC role connection with
yes, yes.
United Convention's target.
Yes. So basically, if we see from political angle, the climate change is not, although scientists accepted climate change as a phenomena induced by human activity, there are some politicians in some countries who are reluctant or who were reluctant to accept this phenomena. For example, Trump administration denied the effect of climate change, and they have their own reasons for that. So, in the first thing in the climate change mitigation and adaptation planning is to accept the climate change phenomena. And United Nations nation and the IPCC is a body who has the authority to deliberate the scientific outcomes and scenarios of the climate change. But as of now, there is no body which can enforce the emission standard. So the this is up to the market and up to the policy makers' wisdom. So they have to come forward. They have to accept and adopt this convention. As you mentioned, UNFCCC is a convention for uh, combating the impacts of climate change. So once you adopt that convention, you have to take measures. But I'll also remember that there is no monitoring body as far as your emissions are concerned, because as we are working in a government organization, we know the limitations of government as well as the industry. So there is no unified body which can monitor the emissions from the industries, from the power plant, from the vehicles. So everything is assumed. So emission from vehicle is assumed as a number of vehicle multiplied by the standard emission. But we do not consider the pollution level, the aged vehicles, the mixed fuel, the quality of fuel. We are ignoring this situation.
Yeah.
So in a nutshell, what I want to say, although we are striving hard for net zero carbon emission, but goal is far to reach. And there are some carrots and sticks for each and every country. And if you say the stock market, so in the stock market, there are some fund manager which advocates the companies which provide environment friendly products. So now what I think as a customer or as a user and as a policymaker, we have to come forward and first accept the phenomenon, number one. Number two, prepare a strategical plan for mitigation of the adverse impact. And third, follow that strategic plan. Since the impact of climate change is a very long period activity, our strategies will also need to be evolved, and it will also take some time.
So like in India, our country, our government has, central government has uh, taken that is National Action Plan for Climate Change, and various
Yes.
ministers have been given various tasks to work under this climate change action plan.
Yes. So what what you mentioned is absolutely correct. Only issue is unless we have a proper climate model and reliable climate model, we cannot have strategies for mitigation, because our strategies are local centric. As I mentioned, the mitigation strategy for Bhor Taluka of Pune district is different vis-a-vis mitigation strategy of Indapur and Baramati, because these two are completely diverse climatic centers, and our strategies cannot be universal for these two tehsils. So
I think
although
in our,
government is striving hard to make policies, but proper implementation of these strategies will tell a story. Yes,
like
please continue.
IPCC, in our country, considering National Action Plan, our Department of Science and Technology have been interested the work of this model and all other the scientific study, I think.
Yes, yes, yes. So whatever you're saying, that part is included in my presentation, and we discuss about that action plan and regions involved in preparation of that action. And there are two missions which are dedicated for mitigating the climate change. So that part is included in our presentation, and we'll discuss that part in detail.
So overall, Kulle sir, this lecture
Yes.
was very interesting. All,
Yes. This is
topics
new
have been
learning
covered.
for me also. And I again, once again, thank to Bhavskar sir and all you participants, because this is a cross learning. I am also learning from you. And since this is not my domain, but I am trying to learn and try to discuss with you and trying to learn again from discussion with you.
And we are hoping that we'll get a maximum input from you. Yeah, as a PhD scholar, get maximum what are the water policies aspect.
Yes,
Yeah,
yes,
that's
yes.
it.
Yeah,
Sir,
so yes, yes.
very nice, sir. Very nicely explaining. But only few concept I just wanted to share.
Yes, please.
The
Yes,
data, most vital role in this model is data, acquisition of data
absolutely.
and validation of data. So how we procure that data and validate it, that is my just query. And secondly, Just I wanted to know when these climate models were performed, as you said, 100 years first we perform and 25 years we check, and then it is validated. So during last 2-3 years we face pandemic. In that
Yes.
2-3 years, all the greenhouse emission gases were very low. So
Mm.
can that affect this model, and can on that basis of 2-3 years data where the all the activities were very slow down, we
Mm.
can go for any mitigation model for this all this climatic change?
Okay, very interesting question. So first, I want to speak about the your first question about the data collection and validation. So now the climate-related data collection is a democratized because earlier there was only one agency, that is Indian Meteorological Department, who is interested with the responsibility of collection of weather-related data. But now, as you know, that Double Water Resource Department also has its own weather stations
Yes, sir.
installed on the catchment area of the dam as well as on the dam, and some weather station in the command area. Also, there are some private agencies like SkyMate, which has their own station and their own models. So, and on top of this, there is a World Meteorological Organization. So, every country has its own governmental mechanism for collection of weather-related data. As far as Maharashtra is concerned, we have IMD, Indian Meteorological Department. We have WRD, Water Resource Department. Then we have Agriculture Department. They installed the rain gauge station and weather station at various locations at Tahsil level. And lastly, we have Revenue Department. They also installed the weather station at each mandal level, and at some mandals where climate diversity is more, at village level also they had installed. So now, in order to correlate your question with the first question, if we get the localized data very easily, so data collection includes installation of the weather station, second calibration of the weather station, third is the collection of data at regular interval. That is most important because real-time data is required for climate modeling. So we cannot say that our station from Pandharpur Tahsil will provide data once in a month, but
Mm.
our station from Nagpur will provide data every 15 minutes. So this inconsistency will not work for climate modeling. Otherwise, our result will be skewed. So standardization of the climate parameters, standardization of the instruments, apparatus, and the collection methodology and validation plays important part. Fortunately, we are moving in the direction because World Meteorological Organization and IMD are going hand in hand, and also there are standardization about the data collection. So from that perspective, data collection methodology and validation methodology is streamlined, and that activity is going at good space. The only concern is the time interval at which data is collected is a issue, and second is the density of the data collection, data point. So more the data sources, more accurate will be result. So that's the only concern. So that is the answer as far as your question
Yes,
number
sir.
one is
Yes, sir.
related. And as far as so as you rightly pointed out that there are some events like COVID-19 pandemic, which was not predicted by any climate change model. So
Yeah.
in my last slide, the challenges for the climate change model, this point is mentioned that there are some future scenarios and outcomes which are not predicted. So COVID-19 is not exactly the climate related disaster. It is a medical or health related disaster, but it affected the climate model because everything was at standstill for about 1 year, and because of that carbon emissions were reduced, but this was not incorporated in the model. So that's why the emissions proposed or predicted by the climate model vis-a-vis emission observed in year 2020 or 2021 were completely different, and that is one of the biggest limitation of the climate model. But fortunately, since these climate models are developed on computer system, and on computer system we have a one law or one rule which is known as a Moore's law. This is very interesting law which says that computing power of our hardware doubles every year. For example, if we buy a mobile phone having suppose 28 megapixel MB memory, the next year our memory gets double. After 1 year, then our memory will be double. So our computing power, processing power, storing power gets double. So there is a very fast exponential rate of the propagation of the computing power, and if using that power plus using tools of artificial intelligence plus machine learning, we can make good computer model for climate change, even though there is a deficiency of data. So scientists are working on these type of models which can have the data, the indirect data. For example, a satellite image can be a type of data. The reflectance observed or collected by the sensor of the satellite can be input, which cannot be converted into mathematical model. But reflectance observed on the image can be correlated with the temperature. So this is one type of example. So secondary database can be used in order to model our climate. So that activity is going on, but it will take a time. So now we are trying to make a model. So once our model is ready, next step is calibration. So calibration also requires some time. After calibration, we have to validate the model. We have to arrive at a confidence interval or accuracy of our model, and once that is assured, we can roll out that model for the prediction. So it will again take time, but I am optimistic about the pace of the development of climate model and its development.
Yes, sir. Thank you. Thank you very much, sir. Nicely explained all the facts.
Yes. Thank you. I think other participants.
So my question was same regarding data collection and
Okay.
reliability of that data. It is very important. Accordingly, outcome will drastically change.
Correct.
And,
So in computer science, there is a one term known as a GIGO. That is garbage in, garbage out.
yes.
So if your data is garbage, then you will also get the output as a garbage.
As you said regarding SkyMet now,
Yes.
that technical persons, they also told me how data is created.
Yes.
In that also there are means peoples, they are creating now very drastic.
Yeah, dummy data.
Yes, dummy data.
That is the problem. Yeah. Any other point, comment, suggestion, observation?
Sir, how can we validate the data? Because as far as rainfall is concerned, so trends are varying. So we get data from various meteorological stations, and sometimes some stations are not working properly, and still we are getting the data. So how to check the accuracy of the data?
Okay, so see, if we say about the rainfall as a one data point, so in order, if we have missing data from any of the rain gauge station, so there are probabilistic models based on adjoining rain gauge station. So we can plot isoidal map, and using Thiesen's polygon, we can calculate the probable precipitation at a rain gauge station for which data is missing based on adjoining rain gauge station. So this is possible for a data like precipitation, because precipitation is generally constant over a given area. It has a variation, but that variation can be captured by the adjoining rain gauge station, and using Thiesen's polygon, we can arrive at the data. But as far as other parameters are concerned, like sunshine, rainfall, the humidity, this data is dynamic. So this data changes very suddenly, and propagating or interpolating this data from other rain gauge station is very difficult. And for example, if just imagine a situation where you have 5 railway stations and you have a cloud burst at one of the railway station, and unfortunately the cloud burst was concentrated in the only one railway station which was not operational. So what will happen? All the adjoining railway station will record zero rainfall. The rainfall occurred at the railway station in a huge quantity, but that rainbow station was not working. So it also recorded zero. So as far as your data collection is concerned, you will get all zero value. If you try to interpolate using the JSON polygon, you also get the zero value because all other adjoining railway station has a zero value. But in fact, ground reality is that there will be the huge flood. So data collection and data validation is a big problem, big challenge. And as far as country like India is concerned, we have to do more about this data validation, because most of the data is collected manually. There are chances of human error, the negligence of data, and as I rightly mentioned by someone, there are data manipulation. So people do not go on field to collect the data. They just sit in the office and just write down the data based on their experience and assumption. So these are the challenges in the data collection. But as I mentioned, we have secondary models. So if data is missing from suppose one railway station. So now satellite remote sensing and microwave remote sensing are the tools which are available with us. So if we deploy a microwave based remote sensing, so in microwave remote sensing, there is a sensor attached with the satellite which measures the depth of cloud, the concentration of cloud, the color of that cloud, and it can anticipate the probable rainfall. So this secondary data can be taken, and you can give this data to your model. So there are various techniques, and this field is also evolving. So this was also important question.
Sir, one last question
Yeah.
from my
Yes.
about Earth, and then when we say I model the atmosphere, somewhere I'm not able to digest that fact because it is so vast. I mean, in terms of
Yes.
length, breadth, everything, it is so
Yes.
vast, and areas of Earth are unexplored. I mean, nobody knows what happens
Yes.
there. I mean, why it happens there. So we say that I've modeled an atmosphere. I've had some data points of 100 years history or the future of at least 20, 30 years history and all, or the future.
Yes.
I mean, somewhere throw some light as to what do they do. I mean, it will be at the domain of all these US and other countries who've got some extra money to spend on all this and say I've modeled this. Or is it actually happening? I mean, I've got a basic doubt. Forgive me, a layman's question.
Yeah, question is very,
Can
very,
we
very
first of all model an atmosphere?
Yeah, very interesting question. And in order to answer your question, you have to go through the IPCC first report. So in due course of time, we will discuss in brief about that question. So they tried to understand the science of climate change. And the IPCC recently published its sixth report. So this is a sixth report of the IPCC. And this report had given detailed methodology of the data collection, and they had also created an interactive web page where you can go through the data. I will share the link of that web page after this presentation, and using that web page you can also create your own scenarios. So methodology of data collection of the non-accessible point is also mentioned in the first working group report of the IPCC. And also, as you rightly pointed out, there are also gaps and assumptions behind data collection. But since as time evolved, the gaps will be mitigated, and more accurate data will be collected in the future.
Thank you, sir.
Can
Yes.
host ask any question?
Yes, sir. Pardon?
Can host ask any question?
Of course, sir. Of course.
It's not question, just query. Since you are both working on the climate modeling or our experience on the climate modeling, and also in the policy making also. So how this climate modeling is used by policymakers and how it helping the policymakers to take decisions on the water sector or the climate related issues?
Yes, interesting question, sir. So, in Maharashtra, we prepared a action plan, state action plan on climate change. We call it as MHSAPCC. So, about three meetings were conducted regarding this report under the chairmanship of Chief Secretary of Government of Maharashtra, and all the secretaries of various department are member of this committee. So this I will share the report of our state, Maharashtra state, and this report was created by one of the leading agency uh, in our country. And this report, the report presented by this group has various chapters. So they studied the water scenario of Maharashtra for last 100 years. They calculated the changes in the water availability, rainfall pattern, flood situation, and accordingly they had their own scenarios. So although we can call it as a regional level climate change model, here region is a Maharashtra state, but still as a officer from Water Resource Department, we had also raised our doubts and observation and objections over that report. And as I mentioned, this is an evolving phase. So we are trying to understand the science of climate change for a local region like Maharashtra. And although average, when we try to average the weather information for a diverse state like Maharashtra, the results are completely misleading. So as you rightly pointed it out, that at a policy making decision, policy making stage, it is very difficult to understand the technicalities of this report and make strategies. So that is one of the biggest challenge in implementation of mitigation strategy. First, it is very difficult for a policymaker to believe on the outcome of the report presented by the researchers, because their outcome are based on a larger geographical area. And as a policymaker, I know the ground reality. The temperature at one part of the state is entirely different than the other part of state. So I cannot believe on this data presented by the scientists. And if even though I believe this data, I cannot prepare a strategy. So just telling me that the average annual rainfall will increase by 11% is not much help to me. It is just, it will improve my knowledge level. But from implementation point of view, it is not that much useful. If my, so as a policymaker, if I know that the average annual precipitation will increase by 11%, my next question is where it will increase, in which state or in which district, in which tahsil it will increase. Second question, can I build new dams? Can I harvest this water? Third question, what is the intensity of rainfall? What will be the yield? So these questions are unanswered because these 11% number are from a climate model. It is not a localized climate model. It is a climate model for entire world, and subset of that is a regional level climate model. So from policymaker point of view, we are also facing a dilemma about the accepting the recommendation of the climate outcomes, the outcomes made by the model. And second most important challenge is drafting the implementation strategy. So as a policymaker, we have to give a clear-cut directions that, for example, for a Pune district, you save, you reduce your water storage or water use by 10%. If I want to give this direction, I want water availability and water demand data for Pune district. That data is not available. So this is one of the challenge from policy making perspective. Okay, sir.
Any other question?
Any other point?
From my side, no, sir.
Okay. So shall we continue now?
Yes, sir.
Yes. So after having a very good discussion about the climate model, we will discuss the basics of climate model. So as I mentioned, climate models are computer simulation that use mathematical equation to represent interaction between basically four areas: atmosphere, ocean, land surface, and ice. And it also has other component of the earth climate system. We will discuss this component in due course of time. These climate models are based on fundamental principles of physics, chemistry, and biology. They incorporate data from observations of past and current climate conditions. So now we've discussed the basic general circulation model and regional circulation model. This is the second part of my presentation, which is the most important part. So general circulation model, a model which is also known as a global climate model, because this model gives climate related information for entire globe. The GCM is a type of numerical model used to simulate general circulation of the Earth's atmosphere and ocean. So basically this model includes two models. First is a Earth atmosphere model. Subset of the model is the atmosphere and another subset is the ocean. So these models are based on the fundamental principles of fluid dynamics. Fluid includes water, vapors, humidity, the wind, and all the ingredients of the atmosphere. So fluid dynamics is an important subject area for formulating this model. Second is the thermodynamics. The principles of thermodynamics are applied for generation of this model. And third is a conservation laws, conservation of energy, conservation of momentum. These laws are applied while formulating these models. These models, the general circulation models, are used to study Earth's climate system and make projections about future climate change. So now you can understand, now we are at the level of understanding the climate situation of our Earth. If in future, if we want to study the climate situation and climate change impact on the moon, you will realize that we have to carry out entire exercise for moon also. So now we have at least we have some data about the atmosphere, about the ocean, about the ice, about the climate, and using this data we can generate the model. So general circulation model is an atmospheric model in which includes atmospheric data and sea surface temperature as a boundary condition. So this model uses boundary conditions. So every model requires some boundary condition. So within the boundary condition, all the model, in order to model a system, we have to divide the entire Earth into number of pieces. We call it as a finite elements. So we have to create each climatic zone as a subdomain or finite element of the model, and for each finite element we have to assign the boundary condition. And once these boundary conditions are assigned, that element has to behave within that boundary condition, and interaction with the adjoining element is also governed by the boundary conditions. There are also coupled atmosphere ocean models which combine two models, that is atmosphere model and ocean model. So there are some models which combine two models, that is one separate model for atmosphere and another separate model for ocean, and then these boundary conditions are applied and coupled atmosphere ocean model is created. So if you go through the history of the general circulation model, the first general circulation model was developed in 1960. So you can see that about 75 years ago, the models were developed. And this model was developed based on oceanic and atmospheric processes were combined, and NOAA Geophysical Fluid Dynamics Laboratory developed this model in 1960. These models are still under development and there are uncertainties. Like Rajendra ji rightly pointed out that the COVID-19 pandemic situation was not invasive in the model, and so there are uncertainties in the model, and there are various uncertainties in the model, like economical situation is also uncertainty which is not envisaged in the model. The general circulation model employs mathematical model of the general circulation of the planetary atmosphere or ocean. Now I avoid to go into the mathematical formulation because since this is a policy class, my domain is also not the climate change modeling. I refrain myself, into dive deep into the mathematical modeling. But I just want to say that the general circulation model use Navier-Stokes equation on a rotating sphere with thermodynamic terms for various energy sources, that is radiation, latent heat, etc. These equations are the basis for computer programs which are used to simulate Earth, atmospheres, or oceans. So basically, entire model is governed by the Navier-Stokes equation on a rotating sphere. So Earth is assumed as a rotating sphere, and Navier-Stokes equation is used in order to simulate the Earth condition. Atmospheric and oceanic general circulation model, which is also known as the AGCM and OGCM, are key components along with the sea ice and land surface components. So as we discussed, there are four basic components: atmosphere, ocean, ice, and land, and these four are the key components of the model. GCMs and global climate models are used for weather forecasting, understanding the climate, and forecasting the climate change. So this is the most important slide of the climate model. So we will discuss this slide. If you understand this slide, you will correlate how climate model works. So there are basically 5 components of climate model, which we already discussed, but we will discuss in detail on this slide. So first component is atmospheric model. So the atmospheric model tries to simulate behavior of the Earth's atmosphere, that is air circulation, and that is the wind velocity, wind flow, wind direction, then precipitation, cloud formation, transfer of heat and moisture. So these are the important parameters which are considered in atmosphere model. So once we have data of these parameters for a specific location and for a number of periodical interval, if the data is collected, we can forecast future or past parameters. Suppose we collected a data of precipitation for about 150 years. So based on this data, we can have rainfall runoff relationship, and using this relationship, we can interpolate, extrapolate, or we can back propagate. So based on, once we have a formula, we can use this formula. That formula will have limitation because not all the extreme events may be included in the model, because we have 150 years data, and if we want to map 1000 year return period flood, see if that return period flood is not occurred during this 150 year time, our model outcome cannot provide a data for 150 year or 1000 year return period flood. So these are the limitation of the model, but at least we have something in our hand than nothing. So these are the parameter of atmospheric model. Second important component is the oceanic model. So ocean, atmosphere, and land are the important parameters for monsoon, because monsoon is not a local phenomena, it is a global phenomena. And oceanic model represent movement of ocean current, that is tides, temperature, sea surface water temperature, and temperature variation across depth of the sea, then salinity of the seawater, sea ice dynamics, and other oceanographic processes. So oceanic model itself is a bigger subject than in the climate modeling domain. So all the scientists who are working in the oceanic model, they contribute from their point. They have their own boundary conditions. So you can correlate that atmosphere is above the earth and above the ocean. Land is a part of earth. Ocean is also part of the earth. Ice is also part of earth. And all these 4 components has a boundary conditions. So we have to collect the data of each component across XYZ dimension and again time dimension. And again, this data has to correlate with the adjoining boundary condition, that is ocean, which is adjoining with the land, that is a coastal area. So coastal area is a very peculiar area, and as far as India is concerned, or Sahyadri ranges is concerned, the coastal area has a width of only 30 kilometer. So within 30 kilometer, there is an immense climatic variation. But even if our model resolution is, if it is a 50 kilometer by 50 kilometer, that variation we cannot capture. So again, this is the limitation of our model. And since this is a most crucial intersection of the ocean and land, our boundary condition needs to be matched. So again, this is a trial and error exercise, and the computer algorithms are there in order to match the input parameter and outcomes. So third important climate component of climate model is the land. So land surface models simulate process occurring on the earth surface with vegetation cover, the crop type, crop period, the height of crop, the water consumption of crop, soil moisture, evaporation, exchange of heat and moisture between land and atmosphere. All these parameters are captured from the land surface model, and again its interaction with the ocean model and atmosphere model is also captured. Fourth is the ice sheet model. So ice is important source of the for the water, and it is also alarming the adverse impact of the climate change, because sea level rise is induced because of the climate change. So ice sheet model is required to simulate the behavior of glaciers, ice caps, ice sheets, including process such as melting, calving, and ice flow. So all these processes we are trying to capture and trying to model in a model. And last and most important is the biogeochemical models, which incorporate cycling of carbon, nitrogen, and other elements through atmosphere, ocean, and terrestrial ecosystem. So if we get the data from all these models, again, there are components like human activity, deforestation, economical development, industrial waste. These are also some of the parameters for model and components of the climate model, but these are the basic component of the natural climate model. And if we get the data from all these components, and if we have a robust algorithm which can give a proper output for a given input, we will have a proper climate model. So layers of the climate PCM. So if you understand the last slide, you will understand that there are numerous data for a given grid. So one grid. So basically, what we do in modeling, we divide entire Earth surface into number of grids. And as Mr. Pradumna asked a question, and he raises a doubt regarding the data collection from the ocean. He is right in that dimension, because collection of data from ocean and the polar region is very difficult. We cannot access that data, that location easily, and that too very often. So what we do, we defragment the entire Earth surface and ocean surface into number of zones. So entire ocean can be treated, can be correlated with the several data points. That means in the density of observation on a land is more than the density of observation from the ocean. So ocean can be represented by considering taking a data from limited or from minimum point of view. So there are various layers of global circulation model, and global circulation model depicts the climate using three-dimensional grid over the globe. So we create a grid over the globe. We take a specific grid and we overlay various information for that grid. We assign the data collected for that grid. So data collected was explained in the last slide. So the resolution of this grid varies from 250 kilometer to 600 kilometer. If there is an ocean, our resolution may be 600 kilometer. If that is a land, our resolution is 250 kilometer, and there is a variation. Then we have atmosphere layer, and we have 20 parameters collected from atmosphere. So there will be the grid. A resolution of that grid is 250 kilometer by 250 kilometer. On that grid, we have 20 layers of atmospheric data and more than 30 layers of oceanic data. So basically for each grid, we have 50 data set from atmosphere model and ocean model. If that grid is related with the ocean, then or ice cap, then our data set will also increase. So then it becomes more complicated. And a location like Himalaya, our model becomes more critical because there is a land, there is a ice, and there is a heat. So the model becomes more complex and critical. So now, once we understand how the basic philosophy of formulation of the climate model, we will discuss climate change projections. So global climate model implies a mathematical model of general circulation of a planetary atmosphere or ocean. So based on the thermodynamics of the movement of the wind or energy, the GCM is formulated based on mathematical principle. Now we will discuss the practical implication of the model. So once the model is ready, so how to represent the outcomes of the model, how to create the scenarios from the model, and which are the agencies. So this is the most important, one of the important part of the presentation, because this, whatever we studied earlier was from academic perspective, but for this slide onward is a policy making perspective. So we'll discuss about the IPCC, climate models and scenarios proposed by the IPCC. So what is IPCC? IPCC stands for Intergovernmental Panel on Climate Change. Although there is a word, no word of governmental, there is a no relation of the government as such. This is a completely 100% scientific body, which is headquartered at Geneva in Switzerland, which was formulated in 1988 by two organizations. First organization was World Meteorological Organization, and second is United Nations Environmental Program, UNEP. So these two organizations came together. They formulated in a panel known as the Intergovernmental Panel on Climate Change. So this is a body, non-governmental body, still called as a governmental body, and all the members of this body or the active members are scientists. The objective of this panel is to provide scientific information to governments so that they can use this data or results to develop climate policies. So the one of the important objective of IPCC is to prepare a climate model. In order to prepare a climate model, we have to every stakeholder has to submit, give their data, then contribute for model formulation, then test that model for validation, and once the model is ready, then give the outcomes to the government for policy making. So this was the objective of formulation of the IPCC. So IPCC monitors and assess all global science related to climate change. Whatever happens in the domain of climate change is assessed by the IPCC. And every IPCC report focuses on different aspects of climate change. The IPCC is an internationally accepted authority on the climate change. So nobody raises questions about the authenticity of the research carried out by the IPCC, because this is a democratic process and this is a very scrutinized process. There are about 287 scientists in the IPCC who carry out the research and provide outcomes for decision making. IPCC reports plays a key role in annual climate negotiation held by United Nations Framework Convention on Climate Change. So whatever mentioned by Nilesh ji is reflected here. There is a convention by United Nations, UNFCCC, which is dedicated for climate change impact negotiation, and IPCC plays very vital role in providing all the data sets for making the negotiations. The IPCC fifth assessment report was important influence on the landmark Paris Agreement in 2015. So you must heard about the Paris Agreement, which was done in 2015, and at that time, before the Paris Agreement, IPCC presented fifth assessment report about the climate change, and this assessment report was the benchmark for carrying out the negotiation. So basically, what IPCC did in the fifth assessment report: first, they studied the climate change, that is the climate change modeling. Second, they formulated various scenarios of the adverse impact of the climate change. And lastly, they proposed the mechanism for mitigation of climate change impact. And there was a Paris Agreement. In that Paris Agreement, there was a consensus among all the stakeholder countries that they will reduce their carbon emissions by a certain percentage. So IPCC is very important body, scientific body, which gives inputs for the United Nations and other government organization to formulate their action plans. The IPCC shared the 2007 Nobel Peace Prize with Al Gore for contribution to the understanding of climate change. So Nobel Prize was dedicated to IPCC in the year 2007. So recently, IPCC published or issued 6th assessment report. So in these 2 slides, we will discuss very briefly about 6th assessment report. So what is this 6th assessment report? So this report is about 5,000 pages. So there are basically 3 working group reports. The first working group report was based on physical science and which was published in August 2021. So Pradumna asked a question about the how data is collected, how the model is prepared. So this report gives entire methodology for mapping the model for climate change. So physical science basis is the report which provides all the details related to the model and science related to the climate change. The second working group published its report in February 2022, which highlights the impacts, adaptation and vulnerability of climate change. So first report was totally scientific report. So common man like us may not understand all the complexity about the climate change, but as Bavaskar sir asked, how policymakers take their decision. So this working group 2 report is a basis for a policymaker to take a decision. So what it highlights? It highlights impact of climate change based on the physical science report. Then adaptation strategies and vulnerability of the climate change events. So this is highlighted by the in a second report. The third and most important report was issued in April 2022 by Working Group 3, which is focusing on mitigation of climate change. So there is a model which says that there will be the adverse impact of the climate change. In this, there is a second report which says that there will be the very large scale impacts on humanity, society and ecosystem because of the climate change, and there are some vulnerable areas and population which will be affected very sensitively because of the climate change. And there is a third report which says that how to mitigate climate change. So these 3 are very important reports which were released as part of 6th assessment report. And most importantly, in March 2023, the 6th assessment report was concluded with synthesis report. So if you want to go through this report, you just go through synthesis report. So you just Google it and you will get the report. If you go through the about 12-page presentation created by which is also available on the IPCC website, which highlights the synthesis report, you will understand entire process conceptually. Now, as of now, IPCC began its 7th assessment cycle in 2023. So 7th assessment cycle is going on for releasing the next assessment report, and after 5 years period, they will publish 7th assessment report. So this is a screenshot showing these reports. All these reports are available on IPCC website. The state of knowledge about climate change. If you want to, if you want to go in detail about these reports are available on website. The first report given by Working Group 1, the physical science basis. Second report, impact, adaptation and vulnerability. Third report, mitigation of climate change. And then we have synthesis report. So very shortly, I will discuss the summary of first report. So Working Group 1 gave physical science basis report. So this is very, as I mentioned, this is a very technical report, but whatever I could understand, I tried to discuss with you. So this is a screenshot of one of the chart presented in the report. So what this chart says, this chart, the blue line is a average and global average temperature during 1815 to 2019. So blue line represent a average temperature, and if you can see that till year 1920, the temperatures are more or less, this temperature is average surface temperature of the earth. So you can see that till First World War, the temperature of the surface of earth are more or less same. You can say that till Second World War. But after 1935, you can see that there is a sudden rise in the surface temperatures. And now we can see that in year 2010, the temperature were about 1 degree more than the average temperature for this period, 1950 period to 1900 period. So this average is blue line, and this we can see that in year 2020, the average surface temperature of earth are more than 1.25 degrees centigrade. So this is the observed data. So based on this observed data, they had prediction for future. So what will happen in 2030? What will happen in 2050? What will happen in 2100? So based on this scenario, what will be the global average surface temperature of the earth? So using our model, they prepared scenarios, and based on that scenario, they created climate change impacts. And in order to mitigate those climate change impact, we have to make certain adjustment on ground. If we change our behavior, our business practices, then carbon emission or greenhouse gas emission will reduce, and ultimately global warming will slow down, and it will result in reversal of the phase of climate change to some extent. So this is one of the insight from the report. According to the report, the first working group committee report, physical science basis, says that it is only possible to avoid warming of 1.5 degrees centigrade or 2 degrees centigrade if massive and immediate cuts in greenhouse gas emission are made. So this is very clear-cut finding made by the IPCC that if we take immediate action and cut down our greenhouse gas emission, then we can reduce the temperature by 1.5 degrees centigrade to 2 degrees centigrade. That means we have to close down all the activities, which is not possible. And the second point was already mentioned by me. An interactive atlas was made for a flexible spatial and temporal analysis of both data-driven climate change information and assessment finding in the report. So you can go through this interactive dashboard, and you can see what is data set available for making this model, and what is the climate change assessment arrived from the model. So this is a interactive dashboard having spatial and temporal resolution. So you can study Maharashtra, you can study Europe, you can study, although there is a limitation of the spatial resolution, and also you can study temporally what happened in 2020, what happened in 2019, what happened during the COVID situation, what will happen in year 2032. So all these permutation combinations are possible. This is a finding from Working Group 2 report, that is impact, adaptation and vulnerability. So the report summarizes that there will be an increase in frequency of extreme event occurrence with global warming. So now this we are experiencing this. There will be the increased frequency of droughts, floods, and see the climate change impacts will not be constant or same throughout the globe. It has a regional variability. So at some region there will be drought, at another region there will be the floods, and there is a complexity that one year there will be drought, another year there will be flood, in next year there will be flash flood. So this is the complexity of the climate change modeling. So climate impacts are at the high end of the previous estimate, with all part of world being affected. So this report says that entire world will be affected because of the changes of the climate change. It says that about 3.3 billion people, that is 40% of world population, will now fall into the most serious category of highly vulnerable with the worst effect in the developing world. So countries like India will be the mostly affected, and since as I mentioned, we are covered with the sea, and there will be ocean issues, and will be the ice in the Himalaya, and we will be affected in the we are very vulnerable as far as climate change impact is concerned. This report also highlights that if emission continues on their current path, so if we do nothing, then Africa will lose 30% of its maize cultivation territory and 50% of its land cultivated for beans. So you can see that how that will affect in the global food security. Then if we do nothing, then 1 billion people will face flooding due to sea level rise. So all the coastal area, including Mumbai, Chennai, all the coastal region will face flooding due to sea level rise. Climate change, together with other factors, also increases the risk of infectious diseases outbreak like COVID-19 pandemic. So this is also again highlighted. So climate change will not come as a single event. It will bring other tragedies with it, and then it will become very difficult to mitigate this impact. China will pay the highest financial cost if the temperature continues to rise. So this observation is obtained from a climate change model having economical parameters as input. So in one of the slides we studied there are 5 parameters: atmosphere, ocean, land, then ice, and last was a biogeochemical. Now a climate change model having economy as a parameter, if we have that model, then they found that China will pay the highest financial loss if temperature continues to rise. The impact will include food insecurity, water scarcity, flooding, especially in the coastal areas where most of the population lives due to higher than average sea level rise, and more powerful cyclones. So in year 2019 flood period, we observed that there were 5 cyclones in the Arabian Sea. So as far as 150 years data is concerned, they in a one monsoon year there were not more than 2 cyclones. But in year 2019, we observed that there were 5 strong cyclones. So because of this strong cyclone, we experienced flooding in Sangli, Kolhapur, and Pune, and the western Maharashtra part. And this report says that there will be the more powerful and more number of cyclones if our temperature rises as of now. In the same way, they are rising right now. So overall, the report identified 127 different negative impacts of climate change, and more worstly, there are some impacts which are irreversible. So even though you reduce the temperature, you control the emission of greenhouse gases emission, there will be some impact like there will be some species which will be which cannot sustain the climate change impact even though you reduce the emission. So there some impacts will be irreversible, and this fear is mentioned in the report. This is the last part of the report, which is a synthesis report given by the IPCC. which says that human activities, principally through emissions of greenhouse gases, have unequivocally caused global warming, with global surface temperature reaching 1.1 degrees centigrade above 1850, 900 in 2011 and 2020. Means they predicted that whatever average global surface temperature was there in year average temperature during year 1915 to 900 were increased by 1.1 degrees centigrade in year 2011 and 2020. So this was just a formulation of a sentence from that graph we already discussed. Global greenhouse gas emissions have continued to increase with unequal historical and ongoing contribution arising from unsustainable energy use, land use change, lifestyle, and pattern of consumption and production across regions, between and within countries, and among individuals. It also says that continued greenhouse gas emission will lead to increasing global warming, with the best estimate of reaching 1.5 degrees centigrade in the near term in considered scenarios and modeled pathways. Every increment of global warming will intensify multiple and concurrent hazards. So they say that if there is a increase in 0.1 degree centigrade, it will intensify the impacts and there will be the multiple concurrent hazards. Deep, rapid and sustained reduction in the greenhouse gas emission would lead to a discernible slowdown in the global warming within around 2 decades. So even though we take a step to reduce the greenhouse gas emission, it will take 2 decades. And also there will be the discernible changes at atmosphere composition within few years. So even though we take some steps, in order to revert the adverse impact, it will take some decades. Climate change is a threat to human well-being and planetary health. There is a rapidly closing window of opportunity to secure a livable and sustainable future for all. So you can notice that there are some words mentioned in a bracket like high confidence, very high confidence. So this high confidence means as far as this is a scenario generated from the climate model. And this scenario, they have very high confidence that this scenario will be true. There are 127 impacts of the climate change, but there are some impacts which has a low confidence. That means my model is not that accurate as far as that impact is concerned. But whatever I mentioned on this slide, the outcomes are, the IPCC says that the outcomes are more prominent to occur. That is, we have high confidence that this will occur or this will happen. So once we know that, so I think time is running. Sir, how much time we can extend? I think last 5-6 slides are remaining.
Yes, sir, you can provide
yes.
5 actually.
So, yes. So now if we understand the global circulation model, the regional climate model is a subset of GCM. So very briefly we will go through it. So regional climate model were primarily developed to provide fine scale climate information for impact studies. So as a policymaker or as a citizen or as a consultant, our focus is on regional climate model or my project level climate model. And now we'll discuss how this RCM is developed. RCM are types of numerical models. So RCM is fine-tuned model which is created using global model. So we take the part or grid of the global model, we process that part, we supply additional information, we train our regional model so that it will give regional level results. So it is just like a cutting a cake. From a big cake, we will cut the cake, we'll take out one of the piece from that cake and we will decorate that cake so that it look beautiful and it will have a meaningful outcomes. So it is just like that. While GCMs cover entire globe and typically have grid resolutions of order 100 to 300 km, RCM focuses on specific regions and can achieve grid resolution as fine as few kilometers. So we can have a RCM of 25 kilometer by 25 kilometer grid. Model simulation length up to centennial scale. Spatial resolution. We can have better understanding of regional to local climate change signals. We can have international coordinated regional climate downscaling experiment. So there are some tools and techniques in order to downscale the global model to regional model. The regional climate modeling originated in late 1980s. In India, so now we'll focus on Indian regional climate model. In India, Ministry of Earth Science, that is MOES, Government of India, is interested with the task of excelling and augmenting knowledge and technology pertaining to Earth system. So whatever happens as far as Earth is concerned is a domain of Ministry of Earth Science, and their purpose is to collect the data, augment the knowledge for public safety and socio-economic benefit of the society. The objective of MOEs are conducting related points, early warning of hazards such as cyclone and tsunamis, weather forecast, warnings and advisories for diverse sectors such as agriculture, aviation, motor resources and tourism, climate change. So see, the basic responsibility of studying the climate change, its impact and advisory role is interested with the Ministry of Earth Science. The climate change research and climate services, ocean observation. So this is a nodal agency which collects the data for entire country about the land, atmosphere and ocean and ice. Ocean observation, modeling and ocean services for fishery and shipping. Exploration of sea for resources including freshwater and development of technology. Assessment of marine productivity, exploration of polar regions, earthquake monitoring and research. The weather and climate related activities of the MOS have been undertaken by. So there is a ministry at the central government level, Ministry of Earth Science, but at field level they have Indian Meteorological Department, which has its own weather stations. Then it has National Center for Medium Range Weather Forecasting. So in order to forecast weather, they have this, and they have Indian Institute of Tropical Meteorology, which is situated at Pune. Recognizing the importance of building reliable and strategic knowledge system in climate change, and these agencies are responsible for that. There is a need for addressing issues concerning sustenance of the Himalayan ecosystem in this part of the world. DST, that is Department of Science and Technology of the Government of India, is coordinating and implementing 2 out of 8 national missions on climate change. So there are 8 national missions. Out of that, 2 are implemented by DST as part of National Action Plan on Climate Change. So the NAPCC, so I mentioned about the state Maharashtra State Action Plan on Climate Change. So there is a National Action Plan on Climate Change. So this plan was developed by a National Mission for Sustaining the Himalayan Ecosystem and National Mission on Strategic Knowledge for Climate Change. So these are the 2 missions which are working in order to develop National Action Plan. One of the deliverables of the National Mission for Sustaining the Himalayan Ecosystem and National Mission on Strategic Knowledge on Climate Change is to set up national level programs in different areas of climate change science, adaptation and mitigation and climate change modeling. So now we come to the point. So whatever I told is to pinpoint where climate modeling happens in India. So climate modeling is one such priority area that is to be addressed by the mission. It has been realized that weather and climate scientists are working hard to make a climate model, and India, like many other countries, utilizes both global climate model and regional climate model to study climate change and its impact on the country. While global climate model provide valuable information about global climate patterns and trends, regional climate model offers higher resolution and more localized projections that are essential for understanding regional climate variability and impacts. So RCM are very important from policy making point of view and from field officials point of view. GCMs are used to provide large-scale climate projection for India, including changes in temperature, precipitation, sea level rise, and under different greenhouse gas emission scenarios. This model helps us to understand broad climate trends and global scale teleconnections and influence of influence India's climate, such as El Nino Southern Oscillation and Indian Ocean Dipole. Indian scientists and policymakers contribute to the development and evolution of the general global climate model through collaboration with international research institutions and participation in the global model in comparison process. RCM project provide higher resolution climate projections, and it allows simulation of local climate features such as monsoon dynamics, regional temperature gradients, and precipitation patterns. RCMs are often nested with the GCM simulation using boundary condition provided by GCM to drive their simulation. So these are very technical details. So you just understand that we are taking part from the global model. We are enhancing that model using local information. This nesting helps us to capture the influence of large-scale atmospheric circulation pattern or regional climate, while also resolving fine-scale features. Indian Institute of Tropical Meteorology and Indian Institute of Science, Bangalore, develop and use the RCM to study climate variability and change at regional level. In addition to RCMs, downscaling techniques are used to further refine climate projection for specific regions within India. And there are statistical methods which uses empirical relationship between large-scale climate variables and local conditions to provide fine-scale climate information. So now models and mathematical tools are available for downscaling of the climate models. Downscaled climate projections are essential for assessing the impacts of climate change on different sectors. So see, we have various sectors. Like if we want to develop a model for Maharashtra, we can develop it that. But if we want to develop a model for water in Maharashtra, that is also possible for regional climate model. So we can develop a model for different sector and region within the India, including agriculture, water resources, coastal area, and urban sectors. So this is a very important advantage of the regional climate modeling. So in 2 minutes, I will complete my presentation with the last part of my presentation, that is the way ahead and future work. So first, climate models are a very powerful tool for studying Earth's climate system. We know that, but they have limitations and uncertainties, particularly in simulating small scale processes and feedback mechanism. So this is one of the limitations of the climate model. Then spatial and temporal resolution, we discuss a lot about this, so I will not go in detail about this limitation. The spatial and temporal resolution of the climate model is one of the concern, and we try to address this concern using regional climate model. Then complexity of the process is one of the major issues. The Earth climate system is highly complex with interconnected processes operating across different spatial and temporal scales. So there is an issue. Climate models must simplify and parameterize many of these processes, leading to uncertainties in how they can be represented. For example, if you want to model a cloud formation, precipitation, and feedback mechanisms between the atmosphere, ocean, and biosphere, these are challenging areas. Then we have uncertainties in input data and parameter. We discussed this point in depth. If we have garbage, then we will get the output as a garbage. So whatever input data is available with us, that should be very neat and clean. And if the data is available, our model parameter will give accurate results. And last is a representation of feedback mechanism. So feedback mechanism plays a crucial role in shaping the Earth climate process. Forcing such as greenhouse gas emission. So feedback mechanism means if we give a feedback to our model, what will be the changes in the outcome. However, the climate model may not fully capture the complex interaction. So see, these are the not linear model. This is a completely non-linear and complex model. So if we change one parameter of the model, the outcome given by the model may not be true. So because of the non-linearities involved in this feedback, which lead to the uncertainties in the simulation. And last is the unknown future emissions and socio-economic factors. We don't know what will happen in future, what will happen in the future emission. If we change to the EV, the electric vehicle, maybe if our socio-economic factor changes, then whatever projection we had may not be accurate. But if we know these parameter, we can implement this parameter, then our model can be improved. And this is the last limitation, that is the model structural and parametric uncertainty. So this is a algorithmic aspect of the climate model, which has its own limitation. So at the end, I want to conclude with only this sentence. Despite this limitation, climate models remains indispensable tools for studying the Earth climate system, providing valuable insights to the processes driving past, present, and future climate change. So, in order to derive the past climate scenario, project the future climate situation, the climate models are very useful tool, and day by day we are improving its accuracy. That's from my side. Thank you so much. Sir, if we
Thank
have
you,
any
sir.
question or discussion.
अच्छा काही प्रश्न विचारताय का?
If you have any question, we can discuss. Any question, any comment, any feedback?
Sir, myself Rajni Patil.
Yes.
Just a single question from my side.
Suppose.
Whether we are sure that climate change is not part of natural cycle or so.
Yes, you are also true. So see, when I deliberately not presented the evolution of Earth, because if we see the evolution of Earth, the temperature of Earth is increasing